yesterday we reviewed adding and subtracting polynomials. Today we are reviewing multiplying polynomials. Okay, so before we jump into working with the polynomials, I want to review our product rule for exponents. Okay, so the product rule for exponents, pretty much this is how it breaks down. Remember, when you have an exponent, that's telling you how many of that base there are. So n squared means it's n times n. There's two n's being multiplied. N to the fourth means there's four n's being multiplied. So when we multiply like bases, okay, it's really just listing out how many there are, if that's how you want to show that work. Okay, so there's actually 6 n's. Okay, so then that can be rewritten as n to the 6th. So what you are doing, the shortcut to not have to write those out each time, is to remember that when you multiply like bases, you're actually adding the exponents. Okay, so if you want to write this out to the side, okay, so I'll call the A, and I don't know why I started to put a plus sign there, sorry. So if you're doing n to some power times n to some other power, oh my gosh, what is wrong with me, guys? You're going to do that base, you keep the base, and then you're adding the two powers. That's the rule. So for this one, n squared times n to the 4th was n to the 2 plus 4, which was n to the 6th. Okay, so that's our exponent rule. Okay, so let's try and apply that real quick, make sure we've got that down. If I have p to the 3rd power, so p cubed times p squared, that means I'm going to add the 3 and the 2, because they have a common base, they're both base p, so that is p to the 5th. And that's it. Okay, now if you've got 3 terms being multiplied, here I've got x squared times x to the 5th times x. Okay, I've got all 3 of them are base x, so I can add all of the powers. But this last one doesn't have a power. What do you have to remember? If there's no power on your variable, what's the understood power? Yeah, it's a, whoa, I don't know why that zoomed way out. It's a 1. Okay, so this means this is x to the 2 plus 5 plus 1. So that is x to the 8th. Everybody good with the exponent product rule? Okay, so we have to remember that, because when we go to multiply polynomials, we're going to be multiplying terms that have a common base but different exponents, and we'll have to remember that exponent rule. So when we're multiplying the polynomials, okay, you are going to multiply the coefficients. That's the numbers. Okay, so in case you have forgotten what that term is, coefficients are the number in front of the variable. Variable is the letter, the coefficient is the number. So in this example 1, -3 is the coefficient in front of n. 4 is the coefficient in front of n squared. 2 is the coefficient in front of n. Now, -1 is not a coefficient, it's the constant, but it's still a number, it's still going to get multiplied. So here we've got a monomial, meaning a single term, outside the parentheses, -3n. And it's up against the parentheses, so that means it's being multiplied. So we have to multiply that -3n by each term inside the parentheses. So I have to show that this is distributed to all 3 terms in this trinomial inside. Now, you don't always have to show this line that I'm about to, but for the sake of your notes, I'm going to show we're distributing -3n is being multiplied by 4n squared. It's being multiplied by 2n. And it's being multiplied by the -1. Okay, see, we distributed it to all three terms in that trinomial. Okay, so now when I multiply these, okay, -3 times 4 is -12, and n times n squared would be n cubed using our product rule, right? Because that first n is to understood 1 power, and then 1 plus 2 is 3. All right, now -3 times 2 is -6. N times n would be n squared. And then -3 times -1 would be +3, and then our n. Okay, so we end up with just -12n cubed minus 6n squared plus 3n. Thank you. He's in fifth. I have him fifth period.
Oh, they put it in the wrong.
Okay.
Again. Okay, sorry.
No worries. All right. Feel okay about that? That's doing a monomial times, this one was a trinomial, but it's really times any polynomial in here. Okay, you just have to distribute anything outside the parenthesis that's butt up against the parenthesis like that. There's no plus or minus between it. It means it's being multiplied. You have to multiply it by everything inside. Good? All right, let's flip it over. Okay, so what we're going to review on the back. Okay, back in Algebra 1, or maybe if you took algebraic reasoning, you may have learned the box method. Okay, so this is the box method for multiplying polynomials, and it's aptly named because you see a box. So what you're doing is, and you can see in this example on the left, you've got a binomial times a binomial. So 2 terms in this parenthesis, 2 terms in this parenthesis. So our box is going to be 2 by 2. Okay, x plus 4. You can see that on the top of each column, x plus 4. Okay, so your x plus 4 is here. And then your second binomial, x minus 2, is here. Okay, and then you're multiplying each of those terms by each other. And there's a box to make sure that you do all the multiplication. All 4 boxes should be full. So here in this first top left, I'm doing x times x, which is x squared. And then in this box, it's x times 4, so 4x. Bottom left, it's -2 times x, so -2x. And in this bottom right box, it's -2 times 4, so it's -8. So I've filled that all in. Those are the terms of my product, but you may notice there's 2 x terms. There's only one x squared term, so that's just written as x squared. But I need to combine like terms here to simplify. So 4x minus 2x simplifies here to just plus 2x. And then there's no other constant, it's just the -8. And that's your answer. Okay, it doesn't have to be a binomial times a binomial. You can see in this one over here, you've got a trinomial. So see, they do 3 across. So this box is a 3 by 2 because it's a trinomial times a binomial. Okay, but you do the same thing. You make sure each of these gets multiplied. This box method is not changing any of the math that we do in solving these. It's just organizing the distribution. Okay, it's making sure that that 2v, because that, go away. That 2v needs to be distributed to all 3 terms here. And that's what this top row is showing. The 2v times 6v squared, the 2v times -5v, and the 2v times 4. And then the -7 has to be distributed to all 3 terms. And that's what this bottom row is showing. -7 times 6v squared, -7 times -5v, and -7 times 4. Now we still end up with some like terms we need to combine. So we can see there's 2v squared terms. So those combine. There are 2v terms. So those get combined. But there was only 1 cubed term and 1 constant. So those didn't change. Y'all recognize box method? Does that look familiar? Yeah. All right, let's try one. Okay, on A, I've got a binomial times a binomial. So that is going to be a 2 by 2. 4y minus 5 is the first binomial. And 5y plus 6 is the second binomial. All right, so we have to multiply, each piece gets multiplied by the other. So negative 4y times 5y. So the negative 4 times 5 is negative 20, and the y times y is y squared. So negative 20 y squared. And then negative 5 times 5y would be negative 25y. And then negative 4y times 6 would be negative 24y. And negative 5 times 6 is negative 30. So are there any other x squared terms, or is this the only one? So just negative 20y squared. But there are multiple y terms, so I need to combine those. So that is negative 49y. And then there's only one constant, minus 30. So that's it. Now, like I said, that box method is just organized distribution. Okay, if you prefer distributing without the box, we can do that. I'll do example B that way. Remember, squaring something means you're multiplying it by itself. So y plus 6 times y plus 6. So instead of putting this in a box, I can take the first term and distribute it to the second set of parentheses. So y times y is y squared. Y times 6 is 6y. And then take the next term and distribute it. So the 6 times y is 6y. And this 6 times 6 is 36. And then you still end up with having to combine like terms. There's multiple y terms in the middle. So that becomes 12y. And then you've still got the y squared in front and the plus 36 at the end. So that is the exact same thing you would have gotten if you did the box method. So you can decide, do I like box method? Do I like showing the arrows and distributing and then combining like terms? Totally your preference. Both of these will work to get you the same answer as long as you do them correctly. Okay, I think it's a good way to organize your work in a box when you're dealing with larger polynomials to make sure everything gets multiplied. So in C, we've got a trinomial times a binomial, so it's going to be a 3 by 2. And it does not matter if you go 3 across and 2 down, or 2 across and 3 down. Okay, the direction of the 3 by 2 doesn't matter. You can pick, it doesn't matter which polynomial goes down the side and which one goes across the top. Okay, it'll work out the same either way. So I'm going to do the trinomial on top and my binomial down the side. Okay, and now I'm going to do my multiplying. So 3 times 4 is 12, and y times y squared is y cubed. Okay, 4y times 6y, that's 24y squared. And then negative 7 times 4y is negative 28y. Then 3y squared times 2 is 6y squared. 6y times 2 is 12y squared. Or I'm sorry, just 12y. And negative 7 times 2 is negative 14. Okay, if they're positive, I wrote positives on these. You don't have to. You can put a plus if it's positive or just leave it without a sign. It's understood positive. Just your preference. Okay, but now I'm going to come, the only cubed term is 12y cubed. I know there's nothing to combine that with. Okay, but then I'm going to look here and I've got two y squared terms to combine, which they're both positive. So it combines to positive 30y squared. And I do have to put the plus here because we're combining these terms. And then I've got two y terms, negative 28y and positive 12y. So that comes out to negative 16y. And then you only have one constant, minus 14. Nothing to combine with that. So that's our product. Now D does not need a box method because notice between the parentheses are not butted up to each other. They're not being multiplied. There's a minus in between here. Okay, so I'm not multiplying this stuff by this stuff. Now, there is some multiplication. You've got a monomial out in front of each of those sets of parentheses. So it's like what we did on the front where we have to just distribute the monomial into the polynomial. So 3r times 5s would be 15. Now, what's that going to be when I do r times s? Yeah, I write it as rs. I cannot combine those. Those are different variables. It's not going to be r squared. It's not r times r. It's a completely different letter. So you just write both letters. Okay, and then 3r times negative 4t would be negative 12 RT. Okay, now I also have to distribute this negative r that's butted up against this set of parentheses. So the negative r is distributed to 2s, so that becomes negative 2rs. And then the negative r to 6t, so that becomes negative 6rt. Now, you stop there, or if you have like terms, you combine them. Are there any like terms here? Which ones? The rs and rs. Good. No, that's good. If there's multiple that have R, like this has R and this one also has R, but I can't combine those because this one has an S, this one doesn't. This one has a T, this one doesn't. They have to have the exact same variables to the same powers to be like terms. To be. Yep, I can also combine the RT with the other RT. So I've got two pairs of like terms that I need to combine to reduce this. So the 15 minus 2, so this is 13 RS, and the negative 12 minus 6 is negative 18 RT. And that's as far as I can take that one. Very good. All right, so you have a short and sweet practice over this, just like yesterday. It's only 6 questions. So when you log into your Delta Math, why that's, here we go. You could possibly see yesterday's and today's. Hopefully you only see today's. Hopefully you finished yesterday's. If you have not, you can still do it at full credit. Remember, if it's under the upcoming tab, it's still available for full credit until the date listed over here. Okay, so this one is through Monday. This one's through Wednesday, but they're only 6 questions each from yesterday's assignment and today's. So there's really no reason you can't finish it in class with the time we have left. Now, if anything shows up under past due, where it says late credit available, that means you haven't finished it. Anything here is from the last unit, unit 4, that we just tested on. The most recent 2 are still at 75% credit through this weekend. That's Sunday night. So you can still go back and finish these for 75% credit through Sunday. The rest are all dropped to 50% credit till December 12th. So, I mean, you can go back and do those anytime before December 12th. Okay, so it's not a rush to go back and finish those, but I would try to finish these that are still at 75% credit for sure. Okay, and then just get to these when you have time later. But stay caught up on the current stuff and the ones that are still at 75% credit. And then also double check aware that you have submitted your review for the test the other day. I'm going to put the review and test grades in today and send out an update in Skyward. So be on the lookout for that. When you see that message from Skyward, you'll know that test and review grades are in. But if you have not submitted your review in Aware, that's going to be a 0. Okay, so be sure you get that submitted. Okay, you'll have the rest of class to get that practice done.